So, taking a look at our Unit 9 review here. First thing we're going to start with is our vocab. So we see it's broken up into two chunks. So let's go. We have a sequence that has a common difference. Well, that is our definition of an arithmetic sequence. The common difference, well, that would be the second term minus the first term. Exponential function is, well, that's another word for a geometric sequence. And the nth term is just an unspecified term in a sequence. Linear function, well, that's just another way of saying an arithmetic sequence. A geometric sequence is a sequence with a common ratio. The common ratio is the second term divided by the first term. And then a sequence is just a set of numbers that are in order with a pattern. Alright, going on to our next set here, we're saying if it's arithmetic, geometric, or neither. So essentially what we're looking to do here is take a look at our terms and see what we got. So if I'm looking at the first term and the second term, well, let's check arithmetic first. Go ahead, check it. It doesn't work, right? So that didn't work. So let's check geometric. So if I take the second term divided by the first term, I'll get positive 4. And if I divide these two terms here, that'll give me positive 4 and positive 4. And again, if we keep on dividing, we'll keep seeing that nice common ratio, positive 4. So that means we have a geometric sequence. Over here, we'll check arithmetic first. So I subtract, and I get 20. Subtracting these two terms gives me 20. I see the pattern continues of subtracting 20, so we are arithmetic. For 11, we try subtracting, we try dividing, and none of it seems to work. And thus, we are neither. Over here, we try subtracting, we try dividing, none of it works, so we are neither. Alright, looking at growth or decay. So we know that this just deals with the base of the number. So we look over here, and we can see that it's a positive 2. That's greater than 1. So remember, decay are numbers when the base is less than, or should I say it's between 0 and 1. So in this case, we have growth. Over here, looking at our base of the exponent, we got 1/4. Well, that's definitely between 0 and 1. So in this case, we have decay. All right, moving on. So let's take a quick look at these. So our initial value, if we think about our functions here, the initial value is that number we're multiplying by out front. So the initial value in this case would just be 4. Growth or decay factor, this is the base of that exponential. So here we have 1.4. So our answer is just going to be C. And then lastly, decay rate. So if we think about this base here, we remember that it's always that 1 plus R. So that rate is what R is. So if we go ahead and think about it here, so it's that 1 plus or minus, plus for growth, minus for decay. So figure out the rate. If I take 1.4, and I go ahead and set it equal to here, to 1 plus R. Right? If I subtract, I'd get 0.4 on each side, so my growth or decay rate, this would be growth, because it's bigger than 1. So my rate there is D. Looking over here, initial value, that's what's out front. So we see we have fractions, decimal for multiple choice, so calculator, divide, I get 0.5 for my initial value, that 1/2, so it's D. Our factor, that's our base here, so 1/5, calculator, that would be 0.2. And then lastly, if I want to get that rate, so I'm going to take this down here. And for ease of calculation, since we're using all decimals, let's go ahead and write that as 0.2. And the 1 plus R. So when I subtract, I'd get that negative 0.8 is equal to R. So my rate there, we always think of the rate as just a positive or negative, depending if it's growth or decay, as we've discussed. So it'd be choice A. Because again, it's minus for decay, plus for growth. Okay, for 21, we have find the common difference, the 52nd term, and the two terms in the sequence after the last one. So looking for the common difference, we're told it's arithmetic. So if I'm looking here, we do negative 18 minus 21. So we'd find our common difference, D, is equal to positive 3. So if we want to go ahead and write out our equation, right? So I have A sub n. So 3 n minus 1. Our initial term is that negative 21, so it's got minus 21. Now if I want the 52nd term, that means I'm going to go ahead and plug in 52 for n. So we got 3. And if I do 52 minus 1, that's just 51. So 3 times 51. And then it was minus 21. So we'd get 132. So our common difference was 3. This was 100 and, what was it, 32. No. Yep. Terms in the sequence, so if we just add 3 to those, I'd get negative 9 and negative 6. All right. Find the common ratio, the 8th term, and the next two terms in the sequence after the last one given. So since we're saying to find a common ratio, we know it's geometric. So when we find our common ratio here, we'll find negative 3. So we got negative 3, writing out our term here. Our initial value is negative 2. And then if we want to find the 8th term, we'd plug in 8. Oh, that should say n minus 1. So I got G sub 8. Negative 2 times negative 3, 2, and then 8 minus 1 is just 7. So we get 4,374. Copy that down. All right, good. And then the next two terms, we're multiplying by negative 3. So we have 54 times negative 3, which gives me negative 162. And then if we multiply that by negative 3 as well, that gives me 486. So we have negative 162 and 486 is our next two terms. Sorry, negative 162 and then 486. All right, so we got left here. Good. Okay. All right. For here, we're writing some equations I'm working through. So the population of the subdivision Joliet is 4,000 people. Every month, the population decreases by 12%. So our equation here, we have y is equal to, our initial value is 4,000, and then our rate. So since we're decreasing, we want to think of 1 minus 0.12. Population after 3 months. We would just plug in 3. Calculator, boom, answer. Over here, we have depreciates again. I can say depreciates, not deprecates. Okay, so we got 3,000 is our initial value, minus that 0.15 to the x, and after 12 years, plug in 12, and we're good to go. All right. This one, the watch is tripling in value each year. So it cost us, it's a really expensive watch. There we go. After 5 years, well, we would just plug in 5 and get our answer from the calculator, or by hand if you're feeling adventurous. Alright, we got Mark left a bag of half-eaten Takis under his bed. On the first day, 3 roaches came to visit. Every half hour after that, the amount of roaches doubled. Whoa. So we're looking at doubling, right? So in this one, we have our equation. So we started with 3 roaches, and then we're doubling every half hour. Let's just keep an eye on that. So here, we want to look at how many are going to be there after 3 hours. So 3 hours, and it's doubling every half hour. So 3, there's 2 half hours in an hour, so that'd be 6 is what we're plugging in. So we got 3 times 2 up to the 6. So a lot of roaches. Alright, I believe we're on our last page. We are. Probably the shortest review video we've made all year. Okay, so we're going to sketch the graph of each function, identify the growth or decay, and look at our y-intercept. So if I plug in these numbers for -2, so for -2 in there, that would give me, let's see, 1/2 times -2. So again, depending on how we've done this in the past here, let's just go ahead and use the table the traditional way. So 1/2 up to, throw parentheses around here just in case. We get 12. And then for this one, we'd have 3 times 1/2 -1. We get 6. And at 0, we get 3. And again, for the purposes of graphing, we tend to want to stick with decimals here. I'm just going to go ahead and get our last one as well here while having the calculator open. And again, we've talked about a multitude of ways to graph these as opposed to the point-by-point method, but we'll check it out anyway. So 1.5 and 0.75. I'm going to go ahead and do this other equation here with the calculator just for the sake of it. So we have 2 up to the -2. That gives us 1/4, so that's 0.25. And then we have 0.5, and then 1, and then we have 2, and then we have 4. Okay, so let's go ahead and get our graphs in, all right? So at -2, I'm up at 12. At -1, we're over at 6. 0, I'm at 3. 1, I'm at 1.5, and then 2, I'm at less than 1, right? So we got our graph here. Over here, we have -2, we're at 0.25, at -1, we're at 0.5. We got our equation. Okay, so we've got our graphs, right? On the left, we see we have decay. On the right, we have growth. The y-intercept, that's like our initial value, right? So, my y-intercept here, we can see it goes through +3, despite my missing it a bit with the line there. So we're at 3 over here, and over here we are at 1. So that's it for our Unit 9 review. Short and kind of to the point here. Again, not all methodologies we've discussed have been shown in this video, but if you can do it anyway, as long as we're getting there, we're good to go. All right, happy last unit exam of Algebra 1.